Hello, everyone. Hi, my name's Ben, and I have a door. And I think you all want to see my door. That's my door. I brought a door. I'm from Australia, and I brought a door with me. Some people call me crazy. Yeah, I'm crazy. I'll just wait for the last few people to take their seats. How's the conference been so far? 2 more talks to go and then workshops, eh? It's been fantastic. One thing I'd like to, I have a complaint against Sebastian. Is he in the room? No, he's actually left. Organisers never thank themselves. So as far as is possible, big round of applause for Sebastian, who's run this for years and is absolutely crazy busy with the number of conferences he runs. So Sebastian, if you can hear us, thank you very much. They always thank the sponsors and the speakers, and they never get any of the credit themselves, and it's very much due to them. All right, so my name is Ben Dechrai. I'm from Australia, and I want to talk to you today about opening doors with JSON Web Tokens, which is obviously exactly what you thought JSON Web Tokens are supposed to be used for, right? How many people know what a JSON Web Token is? How many people have actually used them? How many people understand exactly how they work? The hands keep going down. All right, a bit about me, first of all. Who am I? Why am I here? Why have I got any interest in this? Why should I be telling you about it? I've been a software engineer since '99. I started in PHP. Actually, no, I started in, what was it, the ASP-VB. Anybody do that? Horrible, horrible. I learned about PHP and I fell in love, and then I became a real developer. I can't say that at Microsoft conferences. So I've been doing software engineering for a while. I moved to Australia in 2002, a few years later, and I didn't even know what meetups were when I lived in London. Maybe there just weren't any around yet, but I started getting involved in community work and very quickly found that I was really interested in security and privacy, almost at the level of paranoid, definitely. And now I work for Auth0. So I've been working for them since September. I'm a developer evangelist, which is one of those titles that people go, what's that? Are you going to preach to us? But no, what I do is I take the ideas from you and I preach back to Auth0. So my job is basically to make sure that they're doing their job properly. And they pay me to do that. How awesome is that? So that's why I'm here. That's why I want to talk to you. And a bit of background why I thought using JSON Web Tokens for doors would be a good idea. Does anybody remember this news from about 2 years ago, just under 2 years ago? Has anybody heard of the Amazon key system? So the idea is that the Amazon driver can unlock your house and put the package in, which in certain areas of the US where this idea first started was brilliant, because in the US apparently there are people who will drive down the road and steal people's packages, which is rude, really. Does that happen in Germany? No, nor Australia. It's just a US problem. But anyway, it needed a solution, and sure, they came up with a solution, and there was a vulnerability in it. I'll show you how that vulnerability worked in a second. There's the second. So, how does Amazon Key work? Essentially, you've got your truck driver, you've got the delivery driver who comes along with your package, you've made an order from Amazon, and they come along and they get out a device that they've been given, which they then use to connect to your door via Bluetooth. Before they do that, they go to the cloud and get a key, which then gets passed to the door, which then allows the door to check the same service to see whether that key is actually correct. It's like an authorization code of sorts. And if it's valid, then the door will unlock. There was an optional extra that you could get, which was a camera, which you would put on like the table just inside your door, pointing at the door or something, so that when that happened, you could actually see the person coming in and dropping off the parcel and closing the door again, which was a great bit of additional comfort, but it didn't really provide security. It's like a log file. It won't stop somebody hacking your server. It'll just tell you who did it. Maybe. I mean, they might have been wearing a mask. So the idea is that you're then able to see what's actually happened, potentially in real time. So what the first vulnerability found, it's a perfect word, what the first vulnerability found is that if you do so the camera is connected to your Wi-Fi, yeah? So if you do an SSID denial of service attack, if you just flood the SSID with lots of requests, or you start your own SSID with a stronger, more powerful signal, you can essentially kick the camera offline. So the camera can't send pictures back to Amazon servers, which means that you, wherever you are in the world, can no longer see who's in your house. Now, the downside is that if the camera went offline, what would actually happen is the camera wasn't sending a live stream. It was sending a photo every second or half a second or 10 seconds. I don't know how often. But it would just send a photo. And if it went offline, it would just stop sending the photo. And all you saw was the most recent photo from 10 minutes ago. It wasn't ideal. So the idea was, and I don't think it actually got implemented, but the idea was that somebody could open your door, put the parcel inside, close the door, and then not actually lock the door, throw the camera offline, open the door in, go inside your house and do whatever they wanted. So Amazon fixed that problem. Then they had another problem. So this was about a year ago, just over a year ago. The way that this one worked is that, again, the driver would come along, but having a parcel delivered by a malicious person first. So I, as somebody wanted to break into your house, would come along and I would put this box outside your house. Then the delivery driver comes along and drops it off as normal and uses Bluetooth to unlock the door and puts the parcel inside and closes the door. And at this point, the Bluetooth device, Bluetooth's secure, right? It doesn't know what's been said, but you can detect that there's a Bluetooth signal happening. So the Bluetooth device in this box here would basically say, I've detected something's happening. I'm now going to activate. I'm going to do a denial of service on the Bluetooth bandwidth. So now when the Amazon delivery person gets their tablet out and tries to lock the door again, it can't actually connect. The delivery driver walks away, leaving the door unlocked. I come along, I pick up my package, I pick up your package, I walk away, and again, no video, and they haven't been able to lock the door. And I've probably left your door unlocked as well, because I don't care. So now anybody else can break in too. So is there a better way? So these two examples of the way that the Amazon lock didn't work, there's two very different attacks that were implemented. They were both to do with a denial of service, but both of the solutions were different. One of them was a camera, and basically they would tell you the camera's offline. And in the other way, they just needed to make sure that the delivery driver actually locked it and then phoned up if there was a problem. But you're still dealing with human element, trying to work out how to do this. So is there a better way of unlocking a door remotely, if you're not present, you want somebody to get into your house, than the way that Amazon locked it? Or any of the other internet-connected lock providers. So I propose we don't actually connect the door to the internet at all. If the door is connected to the internet, I mean, the door doesn't need internet access, right? If you want to get information from your door, like, is it currently open in real time? Sure. If you want to ask the door what the temperature is, if it happens over a thermometer, then sure. There are reasons to connect devices to the internet, but a door doesn't really have a use case of being connected to the internet. So I thought, rather than doing that, how about we get the delivery driver to go to the internet, use some kind of identity provider to get a token that it then passes to the door via NFC. And the door, with a JSON Web Token, for those of you who had your hand up in the first and second stages, JSON Web Tokens are self-verifiable. They have a signature component. So the door can now look at that signature and say, this is a valid token for me, therefore I'm going to unlock it. So essentially, we've got our native app, or our web app here, and this is just an API. We're just sending a message to the door saying, I want to access one of your services. And in this case, it's get/unlock, or whatever you want your API endpoint to be. But the token is what permits you to do it. We don't need an internet connection for that. So in terms of the camera, this is one bit that I haven't added on yet, but my next step, which I'm going to give you a demo of the door, but my next step after this is to connect a camera. Now, a camera can actually communicate via Bluetooth quite happily. So there's no reason why the device that we're using can't receive the Bluetooth information of the camera feed that back to the cloud instance wherever you're hosting it, and then provide that to the device that you're using. When the camera feed isn't a security concern, it's just a data transmit question that we're trying to solve. So you could do that via the internet, but again, I don't want to open that possibility of the door being connected to the internet at all. We can actually transfer that via the delivery person's device. Of course, the only time we're ever going to want to unlock a door or see who's at the door is if there's somebody at the door trying to get into the door, which means they have a device. If there's nobody there with a device, the door can't communicate with us, but then there's no device there, therefore the door can't be unlocked anyway. It's like a self-solving problem. Does that make sense? All right, I'll get straight into the demo. So that's the concept behind it, but demos are much more fun. So let me just close this down, and we'll bring some windows across. So the first thing you'll notice is there's no PHP in this talk. I say I'm a PHP developer, and most of my code is written in PHP, but I can't write native apps in PHP. And the Raspberry Pi that operates the door, you could use PHP, but Python makes much more sense. But the concept is the same. So let's bring this window across. Can you see that at the back? Is that big enough? That's good? Excellent. All right, so I'm not going to step through this line by line because there's quite a lot to this. But essentially, when you start a new project in Auth0, and obviously I'm going to use Auth0 as an example, but you can use any identity provider for this. It's just OpenID Connect, OAuth, and JSON Web Tokens. So if an OpenID provider supports those, then you're going to be fine. So when you create the new client, the new application in Auth0, you get a bit of stock code that you can download. You can either download a zip file or you can just copy and paste it out of the website. So I've just pasted that all in here, and you can see, if I can find my mouse again, that we've got a bit of code that will basically react to the OpenSesame ://door1. So we're not using HTTPS here because we're talking via NFC. But basically what we're going to do is we're going to send a message via NFC to the door, making a request for the OpenSesame activity door1 to activate. So the application itself responds to that scheme and will load up when the token comes back from Auth0. Yeah? And then the main part that we have here is this make text component, which basically says we're going to create a bit of text, which is going to be the token that we receive back from Auth0 and write onto the NFC chip. And then I grab some stock standard NFC code in order to write code onto the NFC chip. Now I have here a beautifully branded NFC card. I'm going to make this much easier for you to see with the aid of this tool. Go away settings. All right, so now you can all see my phone, which means that if my wife texts me, just ignore that. If my boss texts me, you can read that. That's fine. All right. There's you. Hello, everyone. All right, so I have here an NFC card. It's been brilliantly clad in Auth0 stickers just to make it even more authentic. Is that the word? And here we have a door. So the most important thing about a door is any kind of access mechanism, and you'll notice this is very professionally fitted. I did this once before, and I actually used the gaffer tape on the NFC reader, and then I realized that it created too much static and killed the NFC reader. So I'm being very careful today. I don't recommend this as a final production installation method. Why not? We can discuss that afterwards. So we have the NFC reader here, which is not connected to the Raspberry Pi directly. It's connected via cable. If we come around the back, the cable comes down. See ya. Comes down and it connects into the Raspberry Pi right in there. And then that cable also comes down via this lovely little loop down here and connects up into this little device, which controls this servo. So there's a little motor in there, which then connects to this shaft that will be driven by the servo. So in fact, the exciting parts are all on this side. So let me turn this around. You've seen the NFC card reader now. And then I can pretend to be on the other side trying to get in. Come in. Sorry. Oh, it's open. So that's the setup that we've got on this side here. We've got so the main reason why the NFC card reader is on such a long tail is because if somebody comes in and decides to disconnect this little, try not to get the lights in the camera, this little component here and starts shorting it, if that was actually connected directly to the motor, they would be able to bypass the system. And we don't want them to be able to bypass the security. So that is basically like a data input. But the Raspberry Pi is what actually controls what happens. So they don't have direct access to that. So first security principle, whatever data entry method you have, make sure that the processor is not accessible. So let's now switch to the application I ran. Open Sesame is the brand that I came up with. If there are any copyright lawyers in the audience, I'd love to talk to you about monetization. We're going to hit login. Now, if you notice at the top there, it's a little blurry on that screen, isn't it? Yes. So you wouldn't have noticed, but you would have noticed that it went to a web page. And basically what's happening at that point, whenever you do any kind of identity login with a mobile app, it's going to go off to the identity provider and it's going to get you to log in. And because I was already logged in, it redirected me straight back, and I've now got the create door pass icon as active. Because it's generated a token, it's sent it back to the phone, and the phone is now saying, if you give me a token, don't go to sleep, if you give me a token, I can write onto that token, and you can use it to unlock the door. So let's have a look at what's happening on the door. So here's the Python code running in the background. It's probably some of the simpler. I'm not Python. Is anybody here a Python developer? Oh, good. Don't judge me. So I've got this application called poll tags, which is basically continuously polling for a tag. Oh. Open anyway. Open. Thank you. Let's make that a little smaller. Can you still read that at the back? Great. Okay, so basically we've got a bit of Python code here. With any kind of login mechanism with an identity provider, when you're looking at OAuth and OpenID Connect, you can have two options for hashing. And you obviously need to hash certain keys for the data to be passed around and for security to be upheld. You've got the RSA hash mechanism, which is a public-private key process. And then you've got the HMAC hashing mechanism, which is a shared password process. Now, in this case here, because the device is not necessarily, you would use a shared password where you trust every system in your environment. Because the device is a separate device outside of the realm of our environment and could potentially be reverse engineered and code's gotten taken out of it, and the door could be anywhere, we've got a smaller trust of the entire environment. So we're going to go with an RSA, public-private key, hashing mechanism. So in order to be able to validate the key, we get the public key with which the signature can be verified. And we set up the GPIO, which is basically all the pins on the Raspberry Pi. And we very simply go through. We use the MyFair library, which is the RFID protocol that's used by most of the transit authorities. If you've got like an Oyster card or something similar, they all use that, most of them. And we basically keep looping through. And the way that it works is if the token is invalid, it's going to throw an error. We don't need to do any if-thens, we just catch errors. So assuming that there's no error thrown, we work out how much time is remaining, and then if we're allowed to open the door, it'll print until what time we can open the door, and then it just comes in here, and this particular line here is the magic, not that one. This one here. Change the duty cycle to unlocked position, and it unlocks the door. So let's go straight back into running this. So we've got this waiting coming up, so this is every time it's polling, it's going through and saying, will you let me in? So if I take my token, which I just burnt if I take my physical token, which I've just burnt the JSON Web Token onto, and I hold it up to this door here, I knock first, and I hold it up. Access is denied. Can anybody think of why that might be? Too old. So often you'll have one of these cards to get into your office, and you swipe it and it works. The next morning you swipe it and it works. The next morning you swipe it and it works. You don't want your delivery driver to be able to come back tomorrow and swipe it and it works. So we have a 60-second timeout, because we don't really need them to have access to the door for more than 60 seconds. 60 seconds is enough time to unlock the door, and that's all they need to do, because the locking should be automatic. And by the time 60 seconds is up, they probably haven't left yet, because it's a small enough window that they're likely to still be around. So I'm just going to recreate this door pass, which I'll do by logging in again, getting another token out, create the door pass, and now, if I can switch the camera on time for those at the back. My token's going to expire again. This is going to be fun. I'm just walking around the stage all day. There we go. We can see it now. So we grab the token, we put it in place, and we can see door 1 can be unlocked until Thursday, June the 6th. The door has, in fact, so while I've moved it around, it actually loosened one of my highly secured anchoring mechanisms. There we go, and the door unlocks. So now I can actually open the door, come through. Unfortunately, now it's locked behind me again. But there we have it. So let me just see if the token's still active. It is. There we go. Bring that in, lock it. Thanks. I'll let you all watch yourself. So what are the things that we've seen here? We've seen the JSON Web Tokens, which are usually used for accessing APIs, as like one of them is an API. It could be like a machine-to-machine. But oftentimes we'll get an access token within an application in order to talk to an API. And we're treating a door like an API, which is probably not the way we usually think of these things. A door is usually a client. There would be an application running on there, and it would be reliant on an API to tell it whether or not to open or close. So by looking at the way we manage our security, whether it's the real-world security or non-real-world security, whether it's the devices that we have on our intranets that don't have external connectivity, how do we get those to authenticate? The principle is to re-evaluate the systems that we have and how we treat them, how we categorize them. So normally that would have been a client. Now, one thing that I tried to get a demo working for last night, which is possibly a little bit why I've got black baggers under my eyes, is a flow called device flow. Has anybody heard of device flow in the OAuth 2 spec? So device flow is a new mechanism. I'm going to tell you about it rather than show you the documentation, because that's just going to be boring. But essentially, device flow is a way that we could actually connect this to the internet, but in a slightly different way. So has anybody here got like a PlayStation? Has anybody then tried to get that PlayStation connected to whatever systems they need to log into, whether it's Netflix or the PlayStation's games network or any of those things, and you have to use the cursor keys to try and type the password in, and you're probably going to get it wrong. Meanwhile, all your friends in the room now know your password because you've just... I actually remember our CEO a few years ago doing that with a gun on a wall, and he had to shoot the letters. And one of the SecOps people in the background is just going... Yes. So device flows are really interesting. It's not necessarily new. It's been around for a while, but a lot of the IDPs are starting to bring it on now as a login flow. So the flow is the way you log in. The example you just saw there is a standard login flow where you provide a username and password. It goes off to the server creates a authorization key, which you can then use to retrieve tokens with. There's other kinds of flows for single-page apps that don't require server-to-server communications because a single-page app isn't running on a server. Device flow is one that they brought in for, surprisingly enough, devices. This is a device. So another way you could do this is you could have a QR code, which is basically an identifier for a device, which you can scan with your application, or maybe it's a code that you type in, and it allows you to use a device with a much easier user input mechanism to authenticate a third-party device for doing something. So in my case, I could use a similar kind of app that allows me, rather than scanning or rather than sending an NFC code, I can actually get a code from the device and then send that off to Auth0, which Auth0 will then sign, return the token, which can then be verified by the door. The door still has internet connectivity because it needs to tell Auth0 which code it gave me, and that then closes that loop. Now, the advantage there is that all you need is the ability for the door to talk to one endpoint, which makes it a lot more secure. So the next step that I have in this project is to do device flow on this and to get a camera involved. Let me just switch back to this. It's going to go to the beginning again? It is. For some reason, OpenOffice always goes to the first slide. So this was a 30-minute talk, as somebody quite rightly pointed out. I wasn't trying to stretch for the 45, but I would love to have any kind of questions or interactions with you. I'll just get to the last slide eventually. But if there's anybody in the room who's maybe trying to integrate authentication more with IoT, which is kind of a bit of a new space in terms of linking IDPs in, wants to know more about the device flow, please do ask. Yes?
Have you tried using something less hardware strong, like a microcontroller or something, Arduino?
So interestingly enough, the Arduino is not going to be powerful enough to process the JSON Web Token. Yes, because I actually tried it. I gave this talk in Montreal, and this is the one where my NFC reader died because of static electricity, and I couldn't buy a replacement NFC reader. So what I ended up doing, I'm going to forward that, almost there. So what I had to do was I actually spent 4 hours in an electronics store in Montreal. I just set up camp, and I said, can I just take whatever I want, and when it's working, I'll just pay you whatever I need to? And he said, yes. So I grabbed the only NFC reader they had, but they would only talk to an Arduino. So then I had to connect that to the Arduino, and then to the Raspberry Pi via serial in order to get the Arduino to just read the NFC and pipe it straight through serial into the Raspberry Pi. The card that I used for the NFC card is an 888-byte card in terms of user storage, because the JSON Web Tokens can be quite long. So with a shorter one, you might be able to process that in memory. But the almost 1K file size of the NFC user data is something that the Arduino is not really good at handling.
So you can't process it in a stream or something like that?
That's right. You can't process a stream because you have to rehash the header and the payload in order to see whether the signature is valid. Yeah. Damn, I know. That would have been nice. Any other questions? Nope. All righty. Well, thank you all for coming. I hope it's been interesting. I'd love to chat with you afterwards if you want to come and ask me questions. I know sometimes people prefer to do that outside of the audience context. That's totally fine. If you're interested to see how a door folds up and goes back into a suitcase to Australia, you're more than welcome to come up and have a look at the door itself. If you want to play with the tokens and open and close it and have a look at the code, please come see me. Thank you very much.